Why is gradient crucial for backpropagation algorithm in deep learning? Imagine trying to find your way through a dark maze. You need a guide that tells you which direction to go to reach the exit fastest. In neural networks, this guide is the gradient. It's what helps the network learn from its mistakes. When training a neural network, the goal is to make its predictions as accurate as possible. To do that, the network adjusts its weights and biases, which are like the knobs controlling how it processes information. But how does it know which way to turn these knobs? That's where the gradient comes in. The gradient is a mathematical tool that shows the direction and size of the change needed in each parameter to reduce errors. Think of it as a map that points downhill toward the lowest point, which is the best possible outcome. When the network makes a prediction, it compares it to the real answer using a loss function. The loss function measures how far off the prediction is. To improve, the network needs to know how changing each weight or bias will affect this loss. That's what the gradient tells us. Calculating this gradient involves calculus, specifically the chain rule. The chain rule helps break down complex derivatives into simpler parts. This process is called backpropagation. It starts at the output layer, where the error is highest, and moves backward through the network. At each step, it calculates how much each parameter contributed to the error. This way, the network gets a detailed map of what to change to get better. Once the gradients are known, an optimization method called gradient descent uses them to update the parameters. It adjusts each weight and bias slightly in the direction that will decrease the error. This process repeats many times over many training cycles. With each step, the network gets better at making predictions. Without the gradient, it would be impossible to know how to improve the network, especially when it has many layers and millions of parameters. The gradient makes the training process efficient and scalable. It allows deep learning models, like those behind language tools or image generators, to learn from huge datasets. They keep refining their internal settings, getting closer to accurate results each time. In essence, the gradient is the key that unlocks learning in neural networks. It guides the backpropagation algorithm, helping the network understand how to adjust itself to minimize errors. This simple yet powerful concept is what makes deep learning models capable of performing complex tasks and powering many modern AI applications.